Hello everyone. Today I'm going to demonstrate how a 3 to 8 decoder works using logism. In logism, building a 3 to 8 decoder helps us to deny or match how binary logic selects exactly one output for multiple options. So someone will ask, what is a decoder? A decoder is a circuit that converts binary information from an input line to a maximum of two exponent and unique output lines. For example, a 3 to 8 decoder takes 3 input bits and 8 and produces 8 outputs with only one output active at a time. So starting, we are going to use the select lines. So we are going to use, since we are building a 3 to 8 decoder, we'll be using the 7 inputs. So these are the inputs that we'll be using, that's the output, sorry. These are the outputs, so we'll be using the 8 outputs since it's a 3 to 8 decoder. Then so these are our AND gates that we'll be using for the decoders. So that one too we'll be using the 8 decoders and AND gates. So our select outputs and then our AND gates. So we'll be using 8 AND gates. Each output is made using the AND gate and then the NOT gate. So after we are done with our AND gates, we just move to the select lines. So we map each of the AND gates to an output. So we make sure that the line gets to the break of the output. So we map each of the AND gates to the output. So you do that for all the 8 AND gates and then the outputs that we have here, since you are building a 3 to 8 decoder. So with this done, we'll then move to our select lines. That's the 3 inputs that we have. So with that done, we just move to extending our lines. So we use the note as the our zero or high, low, sorry, and then from where the light green is, it's our 1 or high. So we do this to be able to connect the lines from our select lines to the end gates. So with that done, we just move to connecting the lines. So the A1 0 means we have 0 0 0, so we match it to 0, and then the next one will be 0, then the C is 0, so we match it to the last one. Then we move to A1, which is A is 1, B is 0, and C is 0. So you connect our AND gates to the data input in order to get a successful output. Without connecting the AND gate to the select lines, our processor or microprocessor or address won't get on. So we make sure that the lines does not get joined with another one. So with this, you have to check, and then we on this, and then all the rest of the inputs will be 0 whilst the A0 is on. Then we on the rest, and then we move to the next one, that's the A1. So that's the 0 1 0 0. So we connect the lines to, so it means we have A to be 1, B to be 0, and then C to be 0. So we connect it. So after that, we make sure to on it and see if it's going to work. So we turn off the A0 and turn on the A1 whilst the rest are 0. So this is it, it's on. We move to the next one, which is the A3. Then we connect. So we use the truth table to connect the A, B, and C to its AND gates. Get it? So once you get to the next one, you have to switch off the select lines into 0, and the one you are working on now into 1. So this is it. It's not on in. So now it's on. Then we move to the next one. That's the A3. So we have 0 1 0 for the truth table. So after that you check, and then there is a mistake. So you have to cross check all your lines well and try to see if you are matching them to the right select lines. So once you don't turn off the data input and you are turning on another data input, it's not going to work. So you have to make sure the rest are turned on whilst the one you are working on is turned. The rest are turned off whilst the ones you are working with is on. So currently we are working on the A4, then C is on. So we move to the A6, and then we do the same thing to it. We move to, so don't forget we use the truth table for drawing the lines or connecting the wires together. So you have to turn all off, and then one you are currently working on to be 1. You connect the last one is the D7, and then it has all the select lines or the truth table to be 1 1 1. So A is 1, C is 1, and B is also 1. And you turn on and see if it's going to work, and then turn 1 1 1. We turn this off, then we turn this on. Ta-da! It's working. So this is the 3 to 8 decoder, since it has 3 select inputs and then 8 inputs. So to sum up, a 3 to 8 decoder is a vital component in digital systems. It efficiently maps 3 input bits to 8 unique outputs, allowing for selection and control logic in various devices. Understanding decoder is essential for building and interpreting moves complex digital circuits. Thank you for the time. Bye bye.